In this video, we are covering a Java feature called serialization. And let's see what this concept is all about. Let's look at an object-oriented system that contains several courses. So we have course C1. So this is a course C1. Then a second course C2. This course contains things like the name, ID, number, description, etc. So there is name, ID, description. Then for a C1, there are multiple sections. So S1 is a section, S2 is a section, S3 is a section. So S1 says, this is my course, S2 says, this is my course, S3 says, this is my course, and this course might actually store all these section identifiers too. That is also possible, or section objects. Then there are sections S4 and S5. For C2. So things are getting pretty complicated here. And to add to the complexity, we have student objects, let's say T1, T2, T3, and so on. So section 1 says, I have T1, I have T2, and I have T3 in it. Section 2 says, I have T1 and T2 in it. And section 3 might say I have T4 and T5 in it. So these are all students. So, sorry, maybe T3, T4, and T5. So things are getting quite complicated. Now, suppose we want to store all this information on disk. Now, the section themselves might have all kinds of attributes like the meeting time, location, number of students, etc. Students have their own attributes like the name, address, GPA, and they themselves might say, I'm taking this course. I mean, or I have completed this and such courses. So things are quite involved. And suppose I want to store all this information on disk. But these are not quite linear in the sense it is not as if this is just a sequence of bits. It looks like this course is going to refer to a string object, then it would refer to an ID, which could again be a string object, description could be a string object, but then it could, we could have a section which points to a course object, which itself is composed of all this. So it is not as if this is just a sequence of bits. Everything is a sequence of bits. But if you want to store all this on disk, this whole thing has to be nothing but a sequence of bits, ones and zeros. So you need to convert this entire system into a sequence of bits. So we need to convert a complex graph of objects to a sequence of bits. So that ultimately what it would look like is nothing but It is as if all these objects together form a sequence of bits like that. It is not a trivial matter at all, because after you store this and when you read back, you should be able to reconstruct the entire graph of objects. So you should have some mechanism for saying, okay, here is my first object, here is my second object, third object, and this object belongs to this class, etc., etc. And if you can do this serialization, you can even ship this serial that would also be an object, the serial object over a network to another computer where you can retrieve the objects back and then invoke methods. So this is a very difficult concept, and all of this is done in a very convenient way by the Java feature called serialization. So that is what we are trying to study. So what we are saying is we have a object-oriented system, and we need to serialize all the objects that are currently in our system so that we could ship it over a network or store it on disk. And when we look at that serialized version, we can reconstruct the objects. So looking at, I'm repeating here, you're looking at a sequence of bits. And looking at this sequence, one should be able to say, well, this is my first object, this is my second object, this is my third object, this is a course object, this is a section object, this is a student object, they are related in such and such way. The whole setup is reconstructed from this sequence. So you have to have some complicated mechanism for doing all this. So how can we serialize a collection of objects? It turns out that Java provides an excellent mechanism underneath the covers to let us do this serialization. So let's go through the slides to see how things are done. So, as I said before, we use serialization to store a set of objects on disk or to ship it over a network. So how do we do that? Before we can get into the details of that, let's see how we can manipulate a file on disk. This is a very fundamental concept. We have a disk drive here, which contains a file. And this is our computer memory here. And the file is F1. To manipulate this file on disk, what we are going to have, this is true of all programming languages in general, we have some kind of an object that represents the file. So this object O1, which is representing file F1, when manipulated, will manipulate the file. That is the fundamental principle. You need some object in our memory, computer memory, to represent the file. This object is connected to the file, and when this object is manipulated, the file gets manipulated. For example, if you write to this object, the file gets written. If you read this object, the file gets read into memory, etc. So how do we do that? Let's take some simple cases. To create a file on disk, we can use this Java statement. we have this reference file of type file output stream. This is a class in the Java development kit in java.io. So we create a file output stream some data. This will end up creating a file on disk called some data. If you run this code, you will see that some data will be created in your folder where the program is residing. So wherever you are executing, this file will be created. It will be in the same folder as the class. And to manipulate this file as an object, we put a wrapper on top of it. So we create a object output stream object. This is another class in java.io, object output stream. It uses this file as a parameter. So we are creating an object output stream on top of the file object. See, this file represents the file some data, and this reference or output refers to an object output stream that is actually including the file. Now you can use methods of output to manipulate this file. For example, if you want to write an integer into it, you would write output.writeInt. So this writes out the content of an integer, 7, or you can write out a character, C, or a Boolean value, a double value, and then finally close it. This file will contain all these 4 values that are associated with these 4 primitive variables. So you will have 7, Q, true, and 3.14 as the 4 values in this file some data. Of course, simply printing it out may not make much sense to us. If you want to retrieve that data, you will have to do the code given here. You write code like this: file input stream. Look at this. This is file output stream. Now we are saying file input stream and refer to the same file some data. We created some data in the previous slide. Now we are reading that file input stream. So this connects file to this file some data on disk, and then we are wrapping it into object input stream so we can read this file as an object, and we can read all the data that we wrote in to the file by saying input.readInt, input.readchar, input.read boolean, and input.read double, and store those values back. So we have retrieved all the values. Of course, this requires that you knew that you are aware that you wrote an integer first, then a character, then a boolean, and a double in that order. If you don't know that, you can't do this. You will get an error if you try to read in a different way. Well, that takes care of primitive types. There are corresponding methods for all primitive types, but we are manipulating objects in this course. We are dealing with sections, courses, students, faculty, books, those kinds of things. So how do we read and write object? Obviously, unlike this set of primitive types, you can't have read student, write course, read television, write account, none of that. I mean, there are an infinite number of possible objects, an infinite number of classes. So we can't have methods like readInt, readchar. I mean, you can't have methods analogous to readInt, readchar, writeInt, writechar, etc., because there are too many application created classes in Java. So there is just one method, write object, for writing objects, and a method read object for reading objects. So supposing you wanted to write out a television and an account, maybe unrelated stuff, but doesn't matter. Suppose I have a television object, television, and an account object, account. We create a file just as we did before. I create a file called object data, put it into file, store or refer to it as by through this object file, then create an object output stream, and we can write output.write object television, output.write object account. So any object can be written using this write object, and we can read them back maybe tomorrow by opening file input stream and object input stream as we did for the primitive types. And then we can write in input.read object, we will get a television back, input.read object, we will get an account back. There are some gaps in this code, so this is not completely correct, but I wanted to keep it fairly simple at this stage. So that is essentially what we have for serialization. There are a few little things that we need to talk about. Serialization, writing objects like this and reading them back is all done in the background by Java. So you don't have to do much work. And it takes care of some complicated relationships. For example, if you have this little object diagram where there is a business office, which is of type department. Its name is business office. And there are two staff members who are in this office, who are working for this office. One is Tom, the other one is Harry. And their phone numbers are as given here. They are both in business office. And the business office keeps track of its staff members, and each staff member says, my office is business office. So there is a reference from the staff member to the business office or to the department, and the second staff member also refers to this. And this maintains a list here so that the references are kept in both directions. It is hard to store this. Suppose you store this staff member, then you will store the name Tom, the phone number 1234567. Then you will need to store the department, and where you will write out the name business office. Then when you get to the manager, you are back here, and then you need to again start storing Tom 1234567 and the business office. Then you are back here. So this is an endless loop. So it is a little difficult to break that, and it is done by the serialization mechanism. The serialization mechanism only stores one object for each one of these, unlike something like this where we might end up storing V1 and then two copies of the business office for both of these staff members. There is no, I mean, V1 might be the first staff member, V2 might be the second staff member, and V3 would be the business office for both. So that would be a danger. An endless loop would be another danger. But there is no such problem when we use serialization. Only one copy of each will be stored, and the relationships will be properly stored in the serialized version. We don't have to worry about that. How do we do that? How do we make use of Java's serialization mechanism? Although the general case may be slightly involved, in most situations or in many situations, we are able to get things serialized fairly easily. whenever you declare a class that needs to have its objects stored on disk or sent over a network or basically serialized, you write that it implements the interface serializable. So you would write public class course implements serializable. Serializable is an interface in java.io. It has no methods, so you don't have to do anything more. Then you do that for every class for which you need serialization done. Then you need to open a disk file as we discussed earlier, like this, and then an object output stream, and write out all the objects that you want to serialize. So if make sure that all these objects, their corresponding classes, are declared to implement serializable, and use write object to write out all the objects. And when you want to read back, you need to do the reverse, as we saw here. Create a file input stream object and an object input stream object, and then read the objects that you wrote out. So there are some simple protocols for doing this. Let's look at some examples before we close this video. As an example, let us look at this class course, and it has, the course has a name and credits, and there is just a constructor here. To serialize the course objects, you need to have this course implement serializable. I don't have anything other than the constructor and the fields here. I don't need to have any specific methods for serializable, because serializable doesn't have any methods in that interface. So nothing more needs to be done for this particular class. Course collection is going to be a list. It is going to be a collection of courses. So you can add a course to this collection, which will be added to this list courses. Linked list is from java.util, and again, I would like to have course collection stored on disk, so I'm going to serialize it, and I may just make it implement serializable. So nothing more needs to be done for this either. And here is a driver where I create a course collection object, add one course to it, ICS 372 with 4 credits. Then I am going to just store the collection. I'm opening a file output stream called object data, and object output stream is a wrapper on top of it, and I will write the object collection into it. So collection is a course collection, and when I serialize it, it will write out this field, the courses, and in the course of writing that out, it will write the entire linked list, which itself is serializable. I know that from the documentation of linked list. So linked list is serializable. So courses is a serializable object. So it serializes every course object, which will mean serializing the name and the credits. So these are also serializable fields. So everything is serializable. So if I simply write out the object collection, it will serialize all the fields of course collection, which is basically a linked list. And in the course of doing that, it will write out all the courses. So everything gets dumped onto disks. I close it, and here I show how to retrieve it from disk. I create a file input stream object and an object input stream on top of it, and I read the object. So this comes in as an object, I need to cast it as a course collection. I know that this contains a course collection because I am the one who wrote it. I am aware of it. So I know that this contains a course collection. So this will get me the collection of courses, and it will contain each and every course. So if I have all the necessary methods in the collection class, I can retrieve individual courses. I didn't do that so that this doesn't become too bloated. So I didn't want to do that. So you could have get the first course, get any specific course by giving the index. I could do all that, or I can have an iterator. So it is extremely simple in most cases. But if you have a static field, if I had a static field like this, private static int something, or double or maybe static string enrollment type. Doesn't matter what this is. If you have something, a static field, this will not get serialized. Java simply ignores all static fields. So there are, and what if there is a field that is not serializable itself, which doesn't have implement serializable, then that is going to crash, whereas these static fields will be ignored. So not everything gets serialized. So you should remember that.